Today we're going to continue talking about trigonometric functions. All right, so to determine if a function is periodic, you're going to use a graphing calculator to graph the given function. Adjust your window. Usually, if you can adjust your x window to negative 2 pi to positive 2 pi, and then usually, it doesn't matter, but I use a scale of pi over 2. Again, I've just found that that's easiest to read. Your y window, you need to adjust as needed to see the minimums and maximums of your curves. The function is periodic. The function values of f of x repeat themselves at regular intervals. This function is periodic, and what it is if you can picture taking this half, if you can visualize taking this half, picking it up, and putting it on top of this half, if it looks the same, then it's periodic. Notice if I take this side and I try and draw it over here on this side, it's going to look like this. It doesn't lay on top of what's over there. It's not periodic. If I take this half and move it over, it's going to be right on top of this half. It's periodic. If I take this half and drew it over here, it's not periodic. If I take this half and draw it over here, then it's periodic. If I take this half and draw it over here, it's not on top of it, so it is not periodic. This one is periodic because I can draw it on the other side. This is periodic. Okay, so it says combining the sine function with x squared. It says graph each of the following functions for negative 2 pi is less than or equal to x is less than or equal to 2x. They're telling you to set your x min at negative 2 pi and your x max at positive 2 pi. And then they want you to justify the vertical window as needed. And then they want you to decide which of the functions appear to be periodic. So if I graph this function, go to y equals and type it in, you get that graph, which we just looked at, and we know that this one is not periodic, because if I drew it on this side, it doesn't lay on top of this one. So this one is not periodic. If I graph x squared, oh look, see, I took this half and drew it over here, it would not look like that half. If I graph x squared times sine x, all right, I get this graph. And again, if I pick up this half and I draw it on the other side, it does not, these two do not look the same, so it is not periodic. If I graph y equals sine x squared, I get this function. And again, if I take this side and lay it over on top of that side, it looks the same, so yes, it is periodic. But if I do sine of x squared, I get this function. And if I pick up this side and move it over here, these two do not look the same, so this is not periodic. Okay, so it says, graph this and state whether or not it appears to be periodic. So hit pause, come back when you're ready, and you should have gotten 3. If you type that in, you get this picture. If I pick up this side and put it next to this, they look the same, so yes, it is periodic. All right, so now to determine if a function is periodic algebraically, you use the period of the original function. For sine, your original period is 2 pi, cosine is 2 pi, tangent is pi. Replace the x in the function with x plus the period, and then simplify. If you get x plus the period equals the original, then the function is periodic. All right, so it says verify algebraically that f of x equals sine x squared is periodic and determine its period graphically. So the first thing we do, we use the fact that the period of the basic sine function is 2 pi. That is, x of sine of x plus 2 pi equals sine of x for all x. Because if I'm somewhere in the unit circle, let's say that I'm here, the sine would be the y coordinate. That would be my solution. If I went 2 pi plus x, then I would go around one time and then up to 2 pi. I've traveled farther, but I'm in the same position, and my answer for sine would be the exact same. So if I take my function here and I replace x with x plus 2 pi. When I do x plus 2 pi, I'm back around to x, okay, which gets me right back to the original function. So yes, it's periodic. Okay, and then if we look at the graph, we could see that the period is actually pi, because this is going from negative 2 pi to 2 pi. So if this is 0 and this is 2 pi, then this must be pi. And you can see there's it. Once it starts to repeat itself, it's starting to repeat again. So this is one period of the function, which is pi, instead of the normal 2 pi that sine usually is, because you squared it. All right, so this one says algebraically determine whether the function is periodic. If it is, determine its period graphically. Sketch a graph showing 2 periods. So again, if I replace the cosine function's period is 2 pi, so if I replace x with x plus 2 pi, I would get this. So instead of x, I put x plus 2 pi. But x plus 2 pi is the same thing as x, because if you travel to x and then go around 2 pi, you're going to be right back at x. So that's going to give me the same thing that I started with, and it's periodic. And if I draw the graph, they're going from negative pi to pi, so this is 0 and this is pi, and you can tell that it starts repeating. Here's 1 pi, here's 2 pi, so it repeats every pi, so the period of this function is pi. Alright. Alright, so it says determine whether the function is periodic. If it is periodic, find the period. Well, what we're going to do is we're going to graph it. So I typed it in, okay? And to determine if it's periodic, I'm going to look at the right side and the left side. So if I pick up the right side and I put it over the left side, does it look the same? I mean, and no, this would not lie on top of it. So no, this is not periodic. Yeah. Alright, so you determine whether this function is periodic. If it is, find the period. Hit pause, come back when you're ready. And hopefully you got pi. Alright, so if I typed it in, it looks like this. This side would lie on top of the, oops, sorry, I thought I separated that. Hold on just a second. Give me a second. Hold on. Come on. Give me my picture back. Okay, I thought I animated it, but I didn't. If you pick up this side and lay it on top of this side, it is on top of it. So yes, it is periodic. And if this is going from negative 2 pi to 2 pi, that's 0, that's 2 pi. So in the middle is pi. And you can see after every pi, it starts repeating itself. So the period is pi. Alright, you try this one, hit pause, come back when you're ready. And you hopefully got not periodic. If I graph this thing and I pick up this side and I set it on this side, it does this, and they do not look the same, so it is not periodic. Okay, to find the domain, range, and period of a function. The domain, find your domain of the original function, graph the function given, see if the domains are the same or different. For range, find the range of the original function, graph the function given, see if the ranges are the same or different. For period, graph the function, determine the period of the given function graphically. Alright, so it says find the domain, range, and period of each of the following functions, sketch a graph showing 4 periods. Alright, they want the absolute value of tangent of x. Well, this would be what tangent x looks like. If you're going to graph the absolute value of tangent x, do you see all these bottom parts, these negative parts? They're going to flip up. So this one is going to turn into this. This one is going to turn into this. This one's going to turn into this. This one's going to turn into this. So you end up with this function. Okay, it took all the pieces below and it flipped them up. So now you have these, I don't know what you want to call them. I don't know, it looks like bombs. First thing that came to my mind. Anyway, so we have the same period because if you notice, one period of tangent would be from negative pi over 2 to pi over 2, and that would be a value of pi. And you can see here, this goes from negative pi over 2 to positive pi over 2. We finish a section, or a period, because here it starts repeating. So from here to here is a period, which from negative pi over 2 to 0 to pi over 2 would be an interval of pi. So the period is, we need domain, we need range, and we need the period. The period is pi, just like tangent is. Your domain goes from negative infinity to infinity, but it skips all of these. So it skips all of the odd multiples of pi over 2. See how this would be 1 pi over 2, that's odd. This would be 2 pi over 2, that's even. It's defined there. 3 pi over 2 is an odd multiple of pi over 2, so it's not defined. So your domain is all reals except odd pi over 2's. Your range doesn't, there's nothing below here because of the absolute value, so your range goes from 0 to infinity. Alright, I think I animated all this. Your domain, wherever tan is defined, so is the absolute value of tan, so the domain of f is the same as the domain of tangent. Your domain of tangent is all reals except for odd multiples, that's the word I forgot, odd multiples of pi over 2, so the domain of the absolute value of tan is all reals except odd multiples of pi over 2. Your range, the range of tangent is negative infinity to positive infinity because it goes from bottom to top, but when we did absolute value it turned all the negatives upside right, or up, whatever, moved them up. So the range of the absolute value tangent must be greater than or equal to 0, which means it's 0 to positive infinity. And I think that should be square because it actually hits the 0. And then what do they want? The period. The period, if we graph it, the period is the same. So the period of tangent is, absolute value tangent x is pi. Alright, so now they want us to do this one, absolute value of sine. Well, if I graph sine x, okay, you can see that the period is 2 pi. Because here's 0, here's 2 pi. It starts from here to here is a period, from here to here is a period, that's 2 pi, that's 2 pi, it repeats itself every 2 pi for sine, okay? The absolute value of sine x, if I graph that, moves all of this bottom stuff to the top. So this part moves up, this part moves up, and you end up with this hopscotch looking thing, or this jumping looking thing, okay? So now what happens is your domain of sine is negative infinity to infinity. It's still going to be negative infinity to infinity because there's no gaps. So the domain of absolute value of sine is still all real numbers. Your range, however, the range of regular sine goes from negative 1 to positive 1. Here, obviously, the negatives turned upside down, so it's your range here is only going to be from 0 to 1. So my range of sine is negative 1 to 1, but my range of absolute value must be greater than or 0, so the range of the absolute value of sine is 0 to 1. And my period, again, for regular sine, it takes 2 pi to complete, but here, from here to here, then I start repeating. Well, this is 0, this is pi, this is 2 pi. I finished a cycle in pi units. There's another cycle in pi units, a cycle in pi units, a cycle in pi units. So the period of absolute value of sine is x. Okay? So on your homework, it's going to look like this. It says, find the domain, range, and period of the following function. Sketch a graph showing 4 periods. So for me, I always graph it first. So if I do cotangent squared x, which by the way, you'd have to type in 1 divided by tan x squared. Oops. And set your mode right. I know I have it right here. I'm just making sure that, make sure I didn't put my things. Make sure that you're in radians. Make sure that you set your window to go from negative 2 pi to 2 pi. And I like to count by pi over 2's. And my y doesn't really matter until you see it, but yeah, there we go. Okay, I want to make sure I had the right graph, and I do. Okay, so you type this in, you type 1 divided by tan, and it's going to put the x here, and you're going to put the squared like that. Okay, so if I graph that, that's what it looks like. It says find the domain, and you can see here that if I'm counting from 0 to 2 pi, that right here is in the middle, right? This would be negative pi, this would be negative 2 pi. So at pi over 2, you can see it's defined. At 3 pi over 2, you can see it's defined. But at pi, at 2 pi, at 3 pi, so on and so forth, then the function is not going to be defined. So we say that it's the set of all real numbers except for n pi, meaning no pi, one or plus or minus 1 pi. You can see right there, there's asymptotes. Plus or minus 2 pi, you can see right there, there's asymptotes. So my answer for domain would be A. It's all the real numbers except for multiples of pi. Because at multiples of pi, you've got these asymptotes. The range, you can see from the graph that it starts at 0 and goes to infinity. And the period, you can tell that it starts, it repeats. Well, that length is from 0 to pi. There's another pi units. There's another pi units. There's another pi units. So the period of the function is pi. And then the graph would be A. Okay? Alright, so hit pause. Come back when you're ready. And hopefully you got 2. All right, and then they didn't put on here, but they want us to find, sorry, hold on, back up. They want us to find the domain and the range and the period. All we did was the graphs, okay? So I just typed it in and I got the graph, which was obviously number 2. Okay? So to get the domain, it's going to be all reals except, and again, all graphs are negative 2 pi to pi, so this is 0, this is 2 pi, so this is pi. So in between would be pi over 2, this would be 2 pi over 2, this would be 3 pi over 2. So you can see at all odd, 1 pi over 2, 3 pi over 2, all odd multiples of pi over 2, my function is defined. Your range is going to go from negative infinity to 0. And your period, it completes a cycle between here and here. That's a unit of pi units. Here to here, that's another pi units. Here to here, that's another pi units. So the period is pi. Alright, try this one. Come back when you're ready. Sorry, should have animated that picture. Kind of ruined it for you there. You got the picture right there for you to answer the question. Alright, the domain is the set of all real numbers except for, I think we answered all of them already and they were the rest of your questions. Oops. Okay, so again, you can see that this would be 0, this would be pi, this would be 2 pi, so this is pi over 2, 3 pi over 2, and you have asymptotes there, which means it's not defined at pi over 2, at 3 pi over 2, at 5 pi over 2, which means that all multiples of pi over 2. That's what this then means. Okay, 1 pi over 2. Oh, 2 plus another 2 pi. Never mind. Yeah. Okay. Then the next one's going to want to know your range. Hit pause. Come back when you're ready. And the range goes from negative infinity. It doesn't go above 0. And the period. Hit pause. Come back when you're ready. And hopefully you got pi. Again, here's negative pi over 2. Here's positive pi over 2. One period got completed. That distance is pi units. So the period is pi. Alright, so how do you combine trigonometric algebraic functions with addition and subtraction? You don't really combine them, but really you do it graphically. Okay, like if you combine a sine x plus a line, this would be a sine wave plus a line, so on and so forth. And then you just graph it and determine from there. Alright, we're at homework, so happy homeworking. And I will see you next time.